Hi, hello everyone. In this video, we discuss about parametric differentiation up to second derivative. Before we go to the differentiation of parametric equations, so let's take a look. What is parametric equations? So parametric equation are equation that having x and y in terms of a third variable. Let's say t. So t is called a parameter. For example, x equals to t squared and y equals to t minus 1. So in this case, we can clearly see that x and y equation are in terms of t. So how we differentiate using parametric differentiation? So from these two equations, we will use chain rule to determine dy dx. So the first equation, that is y in terms of t, so we'll get dy dt. And for x in terms of t, we'll get dx dt. So in order to find dy dx, we'll multiply dy dt with dt dx. So it means that we have to reverse the dx dt to become dt dx. Or in other words, we divide. And then to find the second derivative, that is second order derivative. So here we can see that we will differentiate in with respect to t the first derivative, and then we need to divide by dx dt. So in other words, we will multiply again with dt dx when we bring to up here. Okay, so let's see the example here, example 25. So find the first derivative and second derivative in terms of parameter t. If x equals to 2t power of 3 and y equals to 4t squared plus 1. Right. So firstly, we find dx dt. So we know x equals to 2t power of 3. So we got dx dt is 6t squared. Okay, very easy. You already know differentiate power. So bring original power 3 to the front. So multiplied by 2 will become 6, and then the degree will decrease by 1. And then next for y, so we differentiate, we'll get dy dt. So straight away we got 8t, right? Very simple. And then next, using the chain rule, we will find dy dt. Right. So by using chain rule, we will inverse dx dt to become dt dx. So 6t squared will become 1 over 6t squared here. And then we cancel out with 8t. So 4 and 3 here. And then t cancel out t here. So we got 4 over 3t. Okay, so that's for the first derivative. And then to find the second derivative, so using the chain rule also, we will differentiate with respect to t dy dx. And then don't forget also same as here. Okay, we need to multiply with dt dx. Right. So in order to differentiate with respect to t this one, so I suggest you to bring t above. So 4 over 3 t power of negative 1. So when we differentiate, we will bring negative to the front. So negative 4 over 3 t. So degree will decrease further by 1. So t power of negative 2. So we bring t below back. So that's why we got here negative 4 over 3t squared. Okay. So as I said, we multiply with dt dx, that is 1 over 6t squared. So we multiply, so t power of 4 below there, and then 4 and 6 we can simplify, 2 and 3 here. So we count 2 over 9 t power of 4. And then don't forget the negative, because previously when we differentiate here, we got negative. Okay. So that's the answer for the second derivative. using the chain rule. So that's the way we find out using parametric concept. Okay, that is by using chain rule. Right, so next we move to the example 26. So in example 26, given x equals to 2 over 1 over 1 minus t squared and then y equals to t over 1 minus t. So show that dy dx equals to 1 over 4 1 minus t. Right. So first we differentiate. No, before we differentiate, as I said in the previous example, in order to make easier for us to differentiate, we bring power above, that is will become power of -2. So differentiate power. So bring -2 to the front. So become -4 here. And then the power will decrease further by 1, that is -3. And then don't forget inside here. Okay, don't forget, because many people forget to differentiate inside the function inside power. So there is differentiate negative t we got -1. So the impact here is negative. The answer for the SDT is positive. Okay, positive 4, and then bring 1 minus t below, that is 1 minus t power of 3. So that's for the SDT. Right, next for to find dy dt. So in this case we got not constant here, also t. So we may have to use quotient rule in this case, but for the purpose to minimize the working step, so we didn't show the detail how we find out. So if you like, we can show detail like this. So we know u prime is 1 and v prime is -1. So we apply the quotient rule. So dy dt. So remember vu prime, so minus uv prime. So below here we got 1 minus t squared. So after we expand above here, so 1 minus t plus t. So that's why the t we cancel out. That's why we got 1 over 1 minus t squared. Okay. Right. So after we got dy dt, and then we apply chain rule to find dy dx. So dy dt 1 over 1 minus t squared, and then dt dx. So remember dt dx. So we just switch places. So 1 minus t power of 3 will be on the numerator and 4 will be in the denominator. So with that we can cancel out below here, and then we got 1 over t over 4. So they factor out over 4 outside, so 1 over 4, 1 minus t shown. And then the next question, they ask to find the second derivative. Okay. So from the dy dx, remember the formula as shown in the green box. So we differentiate with respect to t, the answer from dy dx, and then don't forget to multiply with dt dx. So from dy dx here, and then we know dt dx is, after we switch places between numerator and numerator, so it becomes like that. So we differentiate first. So differentiate, very simple. 1 over 4, 1 over 4, the constant remain, and then differentiate, 1 is a constant, 0, and then differentiate negative t, we got -1. So this is for d dt, dy dt, dy dx. And then here we multiply with dt dx. Okay. So the answer would be -1 over 16, 1 minus 3, 1 minus t power of 3. Okay. So if you're not very clear, so I can remove the pen here, put the eraser here. Okay. So that's the answer. Okay. So next for example 27. So given, but if you notice in this example, not only in terms of t, but also we have exponent this time. And also here, given the value, so you have to find out the derivative when t equals to 0. So let's see how you solve this question. So firstly, t e power of 2t. So remember, in this case actually we have two terms. So you have to apply product rule. So apply product rule. So we know u is t, so u prime is 1, v is e to t. So e to t times 2. So we got 2e to t, okay? So we apply u v prime plus v u prime, so that's what we get. There is 2t e power of 2t plus e power of 2t. And then we can factor out exponents as usual. Usually if you have exponent, we can factorize the exponent. So e to t in bracket 2t plus 1. And then why only e to t? So as we know, dy dt is 2e to t, okay? So no problem, very simple. Right, so after we obtain ds dt and dy dt, then we apply the chain rule to find dy dx. So remember the chain rule as shown in the light blue box above there. So apply, so don't forget this dt dx. That is we switch places between numerator and denominator from ds dt, okay? So as you can see here, we can cancel out the exponent. So at the end, we got 2 over 2t plus 1. So since we already no more have exponent, so I think we no need to put a bracket below here. So just 2 over 2t plus 1, okay? Right, next. Given when t equals to 0. So in this case, not only we find dy dx, but also we have to substitute the value of t. So substitute t equals to 0. So we got the value of dy dx is 2. Okay, so remember in this question, we have to sub values. So if values t is very easy, it's just straightforward. Right, next. We want to find the second derivative. So don't forget the formula for the second derivative using parametric concept as shown in the green box above there. So apply, that is we will differentiate with respect to t, the answer from dy dx here, that is 2 over 2t. So differentiate. So remember the previous example, so we bring power above here, power of negative 1, so negative 1 bring to the front, so negative 2, 2t plus 1 power of negative 2. And then don't forget, inside here we also got 2t, so differentiate we got 2. So that's why the answer here is 4 and not 2, because we have to differentiate 2t inside also. Okay, so 2 times 2, that's why we got 4. So negative 4 over 1 plus 2t squared. 2t plus 1, 1 plus 2t. Okay, never mind, it's just the same thing. So that's for differential of dy dx in terms of t. And then don't forget here also dt dx. So don't forget multiply with dt dx. So in this case, we don't have exponent to cancel out. Instead, we will join together 1 plus 2t. So here we become power of 3 lah. So 2 plus 1 power of 3 exponent also there. Okay. So that's the answer for the second derivative. I think this time, did we need to sub values also? T equals to 0? Let's see. Yes, we also need to sub values when t equals to 0. So when t equals to 0, the second derivative would be negative 4. So remember, just to remind you, e power of 0 is not 0, but 1. So 0 is 0 lah. So 1 power of 3 is 1. So negative 4 over 1. So that's why the answer is negative 4. Right. Now for example 28. Okay, this time the equation we have combination of exponent and also trigo function. As you can see, for x equation we have cos, and y equation we have sine. And the question asks us to show that the dy dx is actually tangent of pi over 4 plus 3t. So let's see how we solve this question. Right, so first we have to find the component dx dt and also dy dt. So first about dx dt. So this is dx dt. So as you can see, we have uv here. So from here we got u prime 3e3t, and then v prime. So differentiate cos is negative sine, negative sine 3t. We still have 3t here, do not differentiate first. After that, then we differentiate 3t, that is 3. So the answer is negative 3 sine 3t. Okay. So apply this product rule. So as you can see, they put this one at the back, uv prime here. So this is vu prime. Because with the uv prime we have negative sign, so they put at the back. Now never mind, because it is plus, so uv prime or vu prime, no problem which one comes first. And then as you can see, both terms have a 3 exponent 3t, so we can factor out that one. So inside here we got cos 3t minus sine 3t. Okay, so that's for dx dt. Right, next for dy dt. So I show with a different color. Okay, so again also we have u and v here. Then don't forget u prime is also 3e3t, and this time differentiate sign is cos, cos 3t, and also don't forget differentiate 3t, that is 3. So we got 3 cos 3t. Okay, so that's what we got here. So here we go positive. Right, so just like dx dt, so here also we have 3e 3t, so we can factor out. So we got inside there cos 3t plus sine 3t. Okay. Okay, next, after we find out dx dt and dy dt, right, so next we want to find out dy dx. So instead of dy dt times dt dx, we can also rewrite as a dy dt over dx dt. Okay, also the same concept. So we can divide. So we got this one, so that's dy dt, and this one is dx dt. So as you can see, this is the same term that we can cancel out. So we got sine 3t plus cos 3t, and cos 3t minus sine 3t. So how on earth we can show that is actually tangent? So remember, in order to get tangent terms, so we have to divide by cos. So each term we have to divide by cos, that is cos 3t lah. So sine over cos 3t, we got tangent, cos over cos 1. So we got here tangent 3t plus 1 over 1 minus tangent 3t. Okay. So more or less, just like a double angle of tangent or compound angle of tangent, but where is pi over 4 comes from? So let's see the next slide. So we can rewrite, we put 1 at the front here. Okay. So 1 plus tangent 3t over 1 minus tangent 3t. And then, so we replace using the properties. So we know tangent pi over 4 is actually equals to 1. So 1 here we replace with tangent pi over 4. But here we don't replace because in the formula we have 1 minus at the front. So we don't replace 1 at below here. We just replace 1 above here. And then here tangent, in order to make similar to the formula, so we have to multiply tangent over 4 together with tangent 3t at the below here. So with that, then we can relate with the compound angle of tangent. So that is, remember the compound angle of tangent, tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A tangent B. So that's what happened here, and how we relate our answer with the compound angle of tangent. Okay, so that would be the last example for this video. So thanks for watching. And by the way, this is also the last subtopic of the chapter 9. So after this, we will continue with the last chapter, that is chapter 10. So before we move to the next chapter, so don't forget to answer all the questions, especially in the past year question, regarding the parametric differentiation. So make sure you polish your skill, fully understand about parametric concept before we move to the next chapter. So all the best. Goodbye everyone.